Now we move on to another problem based on infinite potential well. It is given that the width of the infinite potential well is 1 angstrom. We have to calculate the separation between the two lowest energy levels, the frequency and wavelength of the photon corresponding to a transition between these two levels, and we have to identify the spectral region corresponding to this frequency or wavelength. So, for infinite potential well, we have energy eigenvalue equation En is equal to n square pi square h cut square by 2 ma square. I am using the same equation we have used while derivation in our notes. So, the width in our derivation is A, so we take it as 1 angstrom. If you are using the limit minus A less than x less than A, then width is 2A, so you have to use the value 2A is equal to 1 angstrom, but in our case it is A is equal to 1 angstrom. Okay, apply all the values. We have to find the difference between the lowest energy levels. So, give n equal to 2 and n equal to 1, take the difference. So, we have 2 square minus 1 square, that is 3. So, apply all the values. We have 1.792 into 10 raised to minus 17 joules. If we convert it into electron volts, this is the corresponding value. This one divided by 1.16 into 10 raised to minus 19 joule per electron volt. So, what you have is 111.99 electron volt. Now, we have to find the corresponding frequency and wavelength. So, for finding frequency, as you know, E2 minus E1, that is delta E is equal to h nu. So, nu is E in joules divided by the value of h. So, you will get 2.71 into 10 raised to 16 hertz, and corresponding wavelength is from equation nu is equal to c by lambda. Apply the value of c and nu, we have lambda 111 angstrom. So, that is that corresponds to ultraviolet region. Coming to a different type of problem, that is something using the procedure we have learned in formalism. Calculate the expectation values, expectation of Ex, expectation of Px of the particle trapped in infinite square well potential or one dimensional box we are dealing with. So, we are familiar with the equation from formalism. We have expectation of X is equal to integral psi star X psi. So, we have to sandwich the operator between psi star and psi for finding the expectation value. So, our wave function in the case of one dimensional box is of width A is square root of 2 by A into sine n pi x by A. To apply it in the equation, we have psi star x psi. Now, this is sine square. So, we are writing it using the equation 1 minus cos 2x by 2. Okay, constant 2 by A is taken outside. Now, we have two terms. Here we will have x minus x cos 2 n pi x by A into dx. So, 2 will be cancelled from here. This one and this one. So, first term gives x square by 2 between limit 0 and A, and the second term, if we integrate it by parts, what we are going to have is a cosine function, and when we first integrate we will have a sine function, then we have to integrate it once more because we have to integrate it using integration by parts because there is an ax here. So, we will have cosine function, and applying the limits we will get value like 1 minus 1 because cos 2n pi a by a means 2n pi. Cos 2n pi is equal to cos 0. So, when we apply upper limit and lower limit, the values will be the same. So, we will have this second term 0 here. So, yeah, it is a square by 2. So, 1a will be cancelled. So, what we have is the expectation value of position operator, that is in the case of a particle trapped in infinite square well potential is a by 2. Similarly, we can find expectation of px. Again, use the wave function, but we have to remember that the operator is minus ih cut d by dx. Operator corresponding to momentum is minus ih cut d by dx. So, we have to find d by dx of sine function here because it is kept inside psi star and psi. So, it is like d by dx operating on sine. So, we have to find d by dx of sine function, that will be a cosine function. Yeah, one more constant is there, this into, I have to write the constant n pi by a dx. Okay, n pi by a. Okay, now we have a sine n pi x by a and cos n pi x by a. That means it is like 2 sin x cos x, that is sin 2x. So, it is written as sin 2x, but when we integrate it, again we will have a cosine function that will be equal to the values of upper limit applied minus lower limit becomes 0. So, the expectation of momentum in the case of infinite square well potential, that is a momentum of a particle trapped in infinite square well potential is 0. Now, we have to calculate the probability of a particle trapped in the infinite potential well. So, it is given that the particle of mass m is trapped in the potential V of x is equal to 0 when minus a less than or equal to x less than or equal to a and infinite otherwise. Evaluate the probability of finding the trapped particle between x equal to 0 and x equal to a by n when the particle is in nth state. So, we use the wave function square root of 2 by a sin n pi x by a, and as you know, probability is mod psi square, that is integral psi star psi dx. Apply the value of psi star psi, we have 2 by a sin square n pi x by a dx. Apply the limits because it is probability to be calculated from 0 to a by n. So, limit is 0 to a by n. Then 2 by a into integral 0 to a by n. Sin square is written as 1 minus cos 2x divided by 2, and when you integrate you will have only the first term, second term will be 0. So, you have the probability 1 by n. Now, if the limit is given as a x equal to 0 to x equal to a by 2, then we have to use the same condition and integrate it in a similar way. The only difference is that you have to change the limit from 0 to a by 2. So, when you apply instead of a by n, when we use a by 2, the value will be half. That means probability in percentage will be 50% chance of finding the particle at the center. A by 2 means it is at the center of the box. Now you can also get a question to calculate the width of the well. So when you are asked to find the width of the well, you have to use the equation for energy, that is En is equal to n square pi square h cut square divided by 2ma square. So all the other values will be given, and it may also be mentioned that the particle is in particular nth state, nth or second or third, like that. Then you may be asked to find the width of the barrier also. If we use this equation, width is a. If we use the equation En is equal to, that is between the limit minus a less than x less than a, then width will be 2a. Then using the equation n square pi square h cut square divided by 8ma square, you have to find the value of 2a. When we use this equation, you have to find the value of a. Here you are going to find the value of 2a. So you can also calculate the width of the potential well. So these are different types of problems you have to calculate from the case of infinite potential well.